Good morning, students.
Good morning.
So today we are going to introduce to a very interesting topic which you come across every day in your daily life. And there are these two teachers who are going to take you to this journey. So enjoy your session.
Yes, ma'am.
Are you ready, student?
Yes, ma'am.
Let's begin. Here we are.
Welcome to Learning Science via Standards, an exciting initiative by the Bureau of Indian Standards. In this initiative, through a captivating series of lesson plans developed by BIS, we explore the world of science and its practical applications through standards. Everything around us, whether natural phenomena or man-made products, can be explained through science. The manufacturing or testing of these products are governed by certain standards. BIS formulates these standards to ensure their quality and safety. The lesson plan we are going to learn in this video is for the product LPG cylinders, a very important product used in almost every household across the country. In this lesson, you will explore the applicable laws and concepts of science used in this application, properties, production processes, and performance evaluation, thereby gaining a deep understanding of its applications and the importance of following the safety guidelines. Let's begin this very interesting lesson plan on LPG cylinders with Mr. Naveen Arora, scientist from BIS.
I am sure you must have seen the LPG gas cylinder, right? So liquefied petroleum gas cylinders or LPG cylinders are portable containers used to store and transport gas for heating, cooking and other applications. They have become a popular source for fuel in households as well as businesses, particularly in the areas where there is no access to natural gas pipelines. They are also used in industrial processes such as welding, cutting and as fuels for vehicles. The history of LPG gas cylinder dates back to early 1900s when propane gas was first discovered. In the 1920s, the first portable LPG gas cylinder was invented, and thereafter its use quickly spread across Europe and North America. Today, LPG gas cylinders are used widely around the world, particularly in the developing countries where the access to traditional energy sources is limited. The working of LPG gas cylinders involves storing the gas in a pressurized container made of steel or aluminum composite. The gas is compressed to a liquid state, which increases its density and allows for more efficient storage and transportation. The gas is released from the cylinder by opening a valve, and a regulator controls the flow of the gas to the appliance. Since you have been introduced to LPG cylinders, now it's time to know what is LPG in these LPG cylinders. Liquefied petroleum gas. It is a type of flammable hydrocarbon gas that is obtained by refining crude oil or processing natural gas. Around 60% of this gas comes from the extraction of natural gas and oil from the earth. The rest 40% is produced through the refining of crude oil. This gas is composed of either propane or butane or a mixture of both.
I hope you all understood what is liquefied petroleum gas.
Yes, ma'am.
Let me tell you something about LPG. Do you know that LPG is odorless? Do you know it is odorless?
Yes, ma'am.
Then how can we smell the LPG when there is any leakage? So I want Shreya to answer this question.
LPG is very dangerous because if it leaks, it can cause fires and explosions. To avoid this, ethyl mercaptan is added to the gas because it has a strong pungent smell and helps us to detect leakage.
Very good. So let's continue.
Now it's time to understand a very interesting and important phenomena called the Boyle's law. According to this law, the volume of a gas is inversely proportional to the pressure of a gas at a constant temperature. The equation of the Boyle's law is V is inversely proportional to the pressure, where V represents the gas volume and P represents the gas pressure. This implies that as we increase the pressure, the volume of the gas will reduce. After a certain increase in pressure, the gas is converted into liquid. This principle is applied in the LPG as the mixture of propane and butane is easily liquefiable. I hope you understand the concept of Boyle's law. Now, Why do we have to liquefy the petroleum gas? It is because LPG, being a mixture of propane and butane, has a low boiling point and high vapor pressure. This makes it easily liquefiable at relatively low pressure and temperature, which can be explained by Boyle's law.
Which property of LPG helps it to be stored in a cylinder?
It is a well-known scientific principle that liquid occupies much less volume or space as compared to the gaseous form of that substance. In fact, LPG compresses to 270 times its volume when it goes from gas to liquid. This property of LPG is utilized to store it in a much smaller container, that is a cylinder. And that's how so much gas is filled inside our kitchen cylinders. But have you ever observed the cylinder and its shape? Our another expert will tell you everything about it.
Before moving forward, I want you all to answer this question: how Boyle's law is applicable in working and designing of LPG cylinder? You give the answer.
Since Boyle's law states that the pressure of the gas is inversely proportional to the volume of the gas at constant temperature, this means that when the volume of the gas decreases, the pressure of the gas increases, due to which the LPG gas cylinder can explode.
Please sit down. Now let's continue.
Hello students, I am Prasoon Yadav, Assistant Director and Scientist B at BIS. LPG cylinder looks simple, but yet it is a very sophisticated device. Here are some of the major parts of the cylinder. The body of the LPG cylinder is made of a low carbon steel which has properties like easy weldability and high strength. Steel is an alloy of iron and carbon. Where cast iron contains around 2% of carbon, low carbon steel contains approximately 0.05 to 0.25% of carbon in iron. Another very important material is brass. Brass is used in the manufacture of valves used in LPG cylinders. Brass is an alloy of copper and zinc.
So students, you have just heard the word alloy. So can you tell me what an alloy is? Okay. I want you to answer.
Alloy is a solid mixture of two elements, one of which is a metal and other may be metal or non-metal.
Why do we need alloys? Can you answer why is the body of the cylinder made of low carbon steel and not stainless steel?
Hello students, I am Meenakshi and I am here to guide you through the fascinating world of scientific principles that play a crucial role in the design, manufacturing, working and testing of LPG cylinders. Today we will delve into some key laws and concepts that underpin this important industry. As the concept of Boyle's law has already been discussed, let us now understand what is Charles' law. Charles' law states that volume occupied by a fixed amount of gas is directly proportional to its absolute temperature, provided the pressure remains constant. V is directly proportional to T, where V represents the gas volume and T represents the gas temperature. In simpler terms, it means that as the temperature of a gas increases, so does its volume. This law is crucial in the manufacturing and testing of LPG cylinders, ensuring they can endure temperature fluctuations without any structural issues.
How does Charles' law apply in the working and designing of LPG cylinder? Okay, you give the answer.
Charles' law states that the volume of a gas is directly proportional to its absolute temperature at constant pressure. This means if the temperature rises, the volume also rises. But this is not the case for cylinder, as in cylinder the volume is fixed. Thus, the pressure rises, which may cause the cylinder to burst.
Good, very good. Sit down please. So now let's continue.
Moving on to the next vital scientific principle, we have Bernoulli principle. Bernoulli's principle states that an increase in the speed of a fluid like a gas occurs simultaneously with a decrease in pressure or potential energy. This principle finds significant application in the design of valves and regulators of LPG cylinders. It ensures that gas flows out smoothly and evenly, maintaining optimal pressure levels.
Can you identify some more devices where Bernoulli's principle is applicable?
Another important law involved in the manufacturing testing of LPG cylinder is the Avogadro law, which states that under the same condition of temperature, pressure, equal volumes of different gases contain an equal number of molecules. This law is instrumental in guaranteeing that each LPG cylinder contains the precise amount of gas it is designed to hold.
Can you give a real-world example that illustrates Avogadro's law in action?
Finally, we have the ideal gas law, which brings together Boyle's law, Charles' law and Avogadro's law to give us comprehensive understanding of gas behavior. The ideal gas law is a cornerstone in the manufacturing and testing of LPG cylinders, ensuring they meet the exact specification for pressure, volume and temperature. These scientific laws are backbone of LPG cylinder technology, guaranteeing safety, efficiency and reliability. Understanding and applying these principles ensures that cylinders you use every day meet the highest standards.
Why is the ideal gas law considered ideal?
Let's now understand some of the important concepts related to the manufacturing of LPG cylinders. The first process is blanking. This is where a circular section is precision cut from hot rolled coils using a punch and die. This process, aptly named blanking, forms the initial shape of the cylinder.
Name some of the important properties of metals.
Next in the line is the integrate process of welding. It's a meticulous fabrication method where two or more parts are fused together using heat and pressure. This creates a joint that solidifies as a part spool. The parts being joined are referred to as the parent material. The material added to facilitate the joint is called the filler or consumable. Depending on the type of welding, these materials take various forms, from parent plates to filler wires. There are several types of welding processes, each selected based on the parent material and the desired properties of the final product.
Which type of welding is commonly used in the manufacturing of the LPG cylinders and why?
In manufacturing of cylinders, submerged arc welding or MIG welding are commonly used for joining the two halves, as it can give a welding thick enough to join both the halves without any leakages, and it can be mechanized to achieve higher production rates. Next is heat treatment. Following welding, we have the heat treatment stage. This involves heating the cylinder to a specific temperature, allow it to soak and then carefully controlling the cooling process. This process is vital for relieving the stress accumulated during welding, ensuring the cylinder's integrity. During welding, the metal is heated to its melting point. During cooling, after the welding process completed, the rate of cooling is different at different points, which induces stresses in the material. The stress relieving treatment involves heating the cylinder at a minimum temperature of 600 degrees Celsius and allowing it to cool under normal air. The cooling rate is uniform throughout the cylinder and hence the stresses are relieved during the heat treatment. Residual stresses are those that persist in a material even after the original cause of stress has been removed. These stresses may be desirable or undesirable. They are induced in a material after deformation or after differential cooling.
I hope you understood the concept. Can you answer this question? Why stresses are developed in metal during the manufacturing of cylinder? Okay, you give the answer.
Well, stress develops in metals due to various reasons such as forging, welding, machining, etc. This causes uneven heating or cooling of metal, which leads to metal deformation.
Good, very good. Sit down please.
Can you all answer this question? How the stresses developed during the manufacturing of cylinders are relieved? Okay. I want you to answer this question.
The stresses are relieved by heat treatment, a process of reheating a metal to a specific temperature and then allowing it to cool down slowly.
Good, very good. Sit down. Let's continue.
Ductility is defined by the degree to which a material can sustain plastic deformation or permanent deformation under tensile stress before failure. The physical property of a metal that can be drawn into the thin wires is called ductility, or ductility is the property of metal associated with the ability to be hammered thin or stretched into wire without breaking.
Why is degree of ductility important for metals?
Let's continue.
In this section, we will discuss about some of the important tests performed on LPG cylinders to assess its performance and conformity to standards. Leakage is tested during two stages. First is the hydrostatic test. A hydrostatic test is a process in which pressure vessels such as cylinders are tested for strength and leaks. Essentially, hydrostatic testing works by completely filling the cylinder up with water, removing the air in the cylinder and pressurizing the system higher than the cylinder's working pressure limit. Any cylinder which does not pass the test shall be rejected. Another important test is the pneumatic leakage test. In this test, the pressure vessel such as cylinder are tested for strength and leakages by filling the cylinder with air, pressurizing it and maintaining the pressure for some time. The cylinder is subjected to air pressure of not less than 1.18 megapascals for a period of 1 minute while immersed in water and shall show no leakage from the body of the cylinder. The cylinder is considered as failed if there is any leakage which is detected by the air bubbles inside the water at the site of leakage. There are also various destructive tests carried out on the cylinder as per the sampling plan. One of them is the burst test and volumetric expansion test. Burst test is carried out on cylinders by pressurizing the cylinder with water gradually by pumping, filling water into it till the cylinder fractures or bursts. Next is the radiographic examination. This test is intended to check weld quality and weld defects in a cylinder during manufacturing process. Fatigue test or cycle test is another important test. It measures the resistance of materials to damage, strength loss and failure under cyclic loads to check the fatigue strength of cylinder. This is to ensure quality during repeated emptying and filling of gas in the same cylinder in its lifetime. Another very important test is tensile test. It is a test in which a sample is subjected to controlled tensile force until failure. Properties that are directly measured via a tensile test are ultimate tensile strength, breaking strength, maximum elongation and reduction in area. From these measurements, the following properties can also be determined: Young's modulus, Poisson's ratio, yield strength and strain hardening characteristics. In the tensile test, a material sample with standardized geometry is subjected to a tensile load. There are two important parameters we determine using this test. The first is tensile strength, which is the amount of load or stress that can be handled by a material before it stretches or breaks. Another is the yield strength. When a force is applied to an object, the object experiences elastic deformation at first. The object will return to its original size and shape when the force is removed, as long as the resulting stress does not exceed the yield stress.
Can you name two major destructive testing carried on LPG cylinders? Okay. Chandan, you answer.
One is burst test, the other is tensile strength test.
Good, very good. Sit down. Let's continue.
Hello again. Now we are going to understand another very important concept, which is the Hooke's law. This law is related to the study of deformation. A change in shape due to the application of a force is deformation. This is the Hooke's law. It states that when an object has a relatively small deformation, the size of the deformation is directly proportional to the deforming load or the force. Here you can see the formula F is equal to K into delta L. Here delta L is the amount of deformation produced by the force F and K is the proportionality constant.
Can you answer the simple question? What does Hooke's law describe? Okay, give the answer.
Hooke's law describes the relationship between the force applied on the elastic material and the resulting deformation, which is the change in the length of the material.
Good, very good. Sit down please. Now let's continue.
Since we have now understood the Hooke's law, it is imperative to understand two important terms. One is the stress and another is the strain. So, what is stress? Stress is defined as force per unit area within materials that arises from externally applied forces or uneven heating or permanent deformation. Stress is given by this formula. This is sigma is equal to F upon A. Here sigma is the stress, F is the force applied and A is the cross-sectional area over which the force is applied. The unit of stress is Newton per meter square. Now let us understand what is strain. Strain is the amount of deformation experienced by a body in the direction of the force applied divided by the initial dimensions of the body. The formula is given by epsilon is equal to delta L upon L, where epsilon is giving you the strain, delta L is the change in the length and L is the original length of the material. The strain is a dimensionless quantity as it just defines the relative change in the shape. A stress strain curve is a graphical representation of a solid material's behavior when subjected to increasing loads. The different regions of stress strain curve are indicated in this figure. There are some important concepts which we can understand through various points on this curve. The first one is the proportional limit. It is the region in the stress strain curve that obeys the Hooke's law. In this limit, the stress strain ratio gives us a proportionality constant that is called the Young's modulus. The point OA in the graph represents the proportional limit. Next is elastic limit. It is a point in the graph up to which the material under stress returns to its original shape when the load acting on it is completely removed. Beyond this point, the material doesn't return to its original position and a plastic deformation starts to appear in it. Another major point on this curve is the yield point. The yield point is defined as the point beyond which the material starts to deform plastically. After the yield point is passed, permanent plastic deformation occurs. There are two yield points, the upper yield point and the lower yield point. The upper yield point signifies the maximum load required to initiate the plastic deformation. Once the plastic deformation has occurred, the lower yield point then signifies the minimum load required to maintain that plastic deformation. Next is the ultimate stress point. It is a point that represents the maximum stress a material can endure before failure. Beyond this, the failure of the material occurs. And finally, we have the fracture point. This is also called the breaking point. It is a point in this stress strain curve at which the failure of the material takes place. One very important property which we should learn now is the Young's modulus.
How does the stress strain curve play an important role in material selection for different applications?
Young's modulus or modulus of elasticity is represented by capital E. It is a mechanical property that measures the tensile or the compressive stiffness of a solid material when the force is applied to it lengthwise. The formula for E is given by E is equal to sigma upon epsilon, where sigma is uniaxial stress and epsilon is the strain.
So, here is an interesting question based on the concept of stress and strain. Can you arrange the given materials based on the increasing order of their elasticity? Number 1 steel, number 2 lead, number 3 glass, number 4 rubber? Okay. I want you to answer this question.
First is steel, then lead, then glass and then lastly rubber.
Good, very good. Sit down.
At last, let us understand what is stress concentration. Stress concentration is a point in a part design where the stress is significantly higher than in the surrounding areas. Stress concentrations are most commonly caused by abrupt changes in the part's geometry, typically around sharp corners, holes, notches or grooves. The cylinder is shaped in a semi-ellipsoidal form to reduce edges and corners, which can create such detrimental stress concentrations.
Welcome again. I will now tell you about how a cylinder is protected from corrosion. Corrosion is a natural process that converts a refined metal into a more chemically stable oxide. It is the gradual deterioration of material, usually a metal, by a chemical or an electrochemical reaction with their environment. In case of cylinders made of steel, the corrosion of iron and steel, which is commonly called as rusting, is held off by painting the cylinder. Let us understand here what is atmospheric and galvanic corrosion. Atmospheric corrosion is a reaction of metal with the oxygen available in the atmosphere to form oxides. Galvanic corrosion is a corrosion which happens when two dissimilar metals are in contact with each other in a corrosive environment. When a galvanic couple forms, one of the metals in the couple becomes the anode and corrode faster than it would all by itself, while the other becomes the cathode and corrodes slower than it would alone. There are three stages of corrosion protection done for a cylinder. First is the metallizing. It is basically a zinc coating through spraying the molten zinc. It is a type of sacrificial coating. Next is the primer coating. For this purpose, zinc chromate primer is used. It is basically protective coating which prepares the surface for painting, ensuring proper adhesion. And the last one is painting. It is also a protective coating for which a synthetic enamel paint is used.
Since you understood the concept of corrosion, can you answer this question? When two dissimilar metals are joined together, what happened to the corrosion rate? Give the answer.
Corrosion rate of both are increased.
No.
Corrosion rate of one is increased and the other is decreased.
Good. Sit down. Corrosion rate of which one is increased and which one is reduced? Anyone?
The metal with the higher affinity for oxygen will have an increased corrosion rate, and the metal with the lower affinity for oxygen will have a reduced corrosion rate.
So now you have heard that cylinders are coated with zinc before the painting process. So can you give the answer to this question? Why cylinders are coated with zinc? You give the answer?
Cylinders are coated with zinc to protect them from corrosion.
Very good. Sit down, please. Now let's continue.
Wow, this is such an amazing world of cylinders, right? Today we learned a lot about this product. So friends, let me tell you some interesting facts about LPG cylinders. LPG gas cylinders have come a long way since they were first introduced in the early 1900s. The earliest cylinders were made of heavy steel and had a capacity of just 40 pounds. Today, LPG cylinders are made of lightweight, high-strength steel or composite materials and can hold up to 100 pounds or more of gas. They are also convenient to use as the gas can be transported and stored easily. However, LPG gas cylinders can be hazardous if not handled properly, and there is a risk of explosion or fire if the gas leaks from the cylinder. As such, it is essential to follow proper safety guidelines when handling and using LPG gas cylinders. As per the guidelines issued by the Petroleum and Explosives Safety Organization or PESO, LPG cylinders in India must be tested and re-qualified for use every 10 years from the date of manufacture. This is to ensure that the cylinder is still safe for use and can withstand the high pressure of the LPG gas inside. LPG cylinders are painted red as this color has the longest wavelength in our visible spectrum. The light having the larger wavelength can be seen from the far distances, as the light having higher wavelength is least scattered. Therefore, this color would be visible from the farthest distance. The color also signifies danger based on connotations. This is also the reason why traffic signals has red color. Cylinders of 33.3 liters water capacity are used in domestic households, and that of 44.4 liters water capacity are used for industrial purpose. Before I sign off, I am excited to share that we have some other existing and upcoming lesson plans in store for you. These lesson plans cover a wide range of topics, allowing you to explore the fascinating world of science and technology. These lesson plans are available on the BIS website www.bis.gov.in under the feature Learning Science via Standards. Stay tuned for more updates on the availability of these lesson plans on the BIS website. Get ready for an engaging and enlightening learning experience. Have a good day.